Mom, am I audible?
Yes, sir.
Headphone is not here. So can you tell me last class what we did?
So your voice is very low, unable to understand.
Just wait a minute. Actually, my yes. Am I audible?
Yes, sir.
Okay. So I was asking that. Uh, can you tell me the topic that we did in the last class?
Preparation of alcohols from alkenes.
And only mechanism we did, right? The
Yes,
mechanism.
only mechanism we did.
So the last topic was mechanism. Okay. Hmm. Uh, we didn't do the by hydroboration oxidation, right?
Yes, sir.
So from the alkenes, is there any doubt in the mechanism?
No, no, sir.
So the basically, okay, I'm gonna give you some question. So you know that when you are going to prepare alcohol from alkene, the intermediate is your carbocation. Alcohol from alkene, intermediate is your carbocation. Is carbocation. And you know what? Whenever carbocation formation takes place, rearrange if possible. Rearrange if possible. Very simple it is. Rearrange if possible. Now I want to say something. Rearrangement we already did in al haloalkanes and halogens. Can you do me a favor? Just you are studying on your laptop or phone.
Laptop, sir.
Okay, just click a photo of the screen. I just want to see how it looks. Actually, when I was teaching on iPad, it was not the complete screen. It was like this type. I just wanted to see. So click it and send it to the Learnivio's admin. I will ask them. Okay.
Okay, sir.
Okay. See. So here is what you are going to do. CH2 double bond CH2, and when you are going to catalytic hydration, it is H2O in the presence of H plus. Okay. So what will happen? Basically, this bond will be broken. One will have positive, another will have negative. Basically, heterolytic cleavage took place. That means one carbon took another carbon's electron, so there is negative charge and there is positive charge. So basically, it will look like this. I'm gonna for explanation, I'm going to write more steps. I'm just gonna remove this positive negative in single step only for explanation. I'm writing since the arrow is in this direction, so I can write CH2 negative and this will be the scenario, right? Can I write this?
Yes.
Now see, this H2O has two parts, H plus and OH minus. So only you need to focus on carbocation. That means carb anion will be attacked by this and it becomes CH3 and CH2 plus. What is this? This is your 1 degree carbocation, right? Yes or no?
Yes.
Now see what will happen. Very simple. If by some default, if you are going to develop positive charge on here, that means you are going to make this carbocation, this carbon carbocation. So it will also be 1 degree, right? So there is no difference if you are doing the rearrangement, shifting, if you are doing, there is no changes. There is no changes. That means stability at this carbon will be same as stability at this carbon. So rearrangement here is not good thing. So what I want to say, OH minus will come to attack on this, and you will get this CH3 CH2 OH. Are you getting my point? Yes or no? Now, if you have this alkene, I'm gonna change the slide. Since this is an addition reaction, so you have to break the bond and add H plus and OH minus. Hence, this is your, if you are going to take this, what will happen? So I can do two things. Either this CH3 and CH and CH to negative here, so it will be positive, right? It will be positive. Or either you can do this. So what will happen? With the below arrow, there will be negative sign and there will be positive sign. Which one is more stable? Which one is more stable? This one, this is 2-degree carbocation, so this is more stable, and this is 1-degree carbocation. It is less stable because in 2-degree carbocation, this carbocation which is having electron deficient will be getting support from two sides, and this carbocation will be getting support from only one. So we will move with this one. Okay. So H2 has two parts, H plus and OH minus. H plus will go with this, and OH minus will go with this, and you will be getting CH3 CH, and here it will be OH and CH3. This is how we are going to do the reaction. In short, we can call it Markovnikov, but be careful because rearrange if possibility is there. In short, you are going to do Markovnikov. That means negative part along double bond having less number of hydrogen, and positive part going towards positive part going towards along double bond having greater number of hydrogen. So this is the scenario. This is the reaction for that. Just write it. Should I slide it up? Let me know when you are done with this. Are you done with this?
Yes.
No. Now the next preparation from alkanes. for alcohols is from hydroboration oxidation. The next preparation is also very important, and that comes out to be the next one is by hydroboration oxidation. By hydroboration oxidation, we call it in short form HBO. And basically, what we do in this, you have heard of borane, that is BH3, and diborane, that means BH3 whole twice. That means you can write it B2H6. This is your diborane. Okay, very simple it is. Now, what you are going to do? You are going to write CH3, CH double bond CH2. Basically, this is your alkene. And if you are going to react this B2H6 in the presence of water and hydrogen peroxide in the presence of alkaline medium, OH negative, you are going to take 3 moles of this in order to balance it. What will happen for this reaction? You are going to especially follow anti-Markovnikov, anti-Markovnikov. And you know that since we have this water, so water has two parts, H plus and OH minus, and according to anti-Markovnikov, this negative part will go to that carbon which has lesser number of hydrogen, and positive to that carbon which has, sorry, negative part will go to that carbon which has greater number of hydrogen in case of anti-Markovnikov, and positive to that carbon which has lesser number of hydrogen, and it becomes CH3, CH2, and here CH2OH. Are you getting my point? If you remember which Markovnikov or anti-Markovnikov in addition reaction you are going to follow, generally in this alkene, it will be very easy. For that alkene, from alkene to alcohol by catalytic hydration in the presence of acid, that is your Markovnikov. This is your anti-Markovnikov. Markovnikov, that means negative to that carbon which has lesser number of hydrogen, and here negative to that carbon along double bond which has greater number of hydrogen. In NCRT, this is given in three steps. I will explain that as well. But if you will remember this, if you know that this is anti-Markovnikov, so it is very, very easy. Okay, if I'm gonna give you a question like this, let's say, and I'm going to do HBO, they can directly write HBO as well, HBO hydroboration oxidation. Can anyone tell me the product? So HBO here, you can see H plus and OH minus is there. This is your carbon. This is your carbon along double bond. This is your carbon. It has one hydrogen. This doesn't have hydrogen. So negative part will go to that carbon which has greater number of hydrogen. Positive to that carbon which has less number of hydrogen. Hydrogen we usually don't show it. So this is the product. The name is very simple. 3-methyl but and singly bonded all butane 2. Isn't it easy? Omam and Austin.
Yes.
Okay. So write it. I'm going to show you the reaction that is in NCRT in 3 steps. Let me know when you are done. Are you done with this? Oh, you are
Yes.
not ordered. Okay. Now see, in NCT, the reaction is very simple. You know what? The reaction is very simple. Basically, we need to take 3 moles of alkene that I used here. Only 1 mole. Basically, when you are going to balance it, we are going to use 3 moles of alkene, and at the product we will get 3 moles of alcohol as well. Okay. Now, how's the reaction taking place? I'm going to show you the same reaction. This is your CH3CH double bond CH and BH3 whole twice. Can I write this BH3 whole twice as HBH2 whole twice? Can I write this? So basically, I'm going to react this with HBH2 whole twice, right? Now see how reaction is, how it is reacting. This bond will be broken. This bond will be broken. Okay, this will have negative as I told you, and this will have positive. As I told you, anti-Markovnikov will be followed. So this will be going to this carbon, and this positive will be going to this carbon. So what we will have is very simple, CH3 and then CH and one hydrogen add up to that CH2 and this becomes CH2, BH2, BH2, BH2 and H2 I'm going to write BHH bond. Okay. Now again I'm going to take another mole of this CH3, CH double bond CH2, this protein another mole. Now again what I'm going to do, break this bond and break this bond. Now you know that this is positive and this is negative. So this positive part will be coming to this carbon and this negative part coming to this carbon. Okay. So again I'm going to write, first I'm going to write this one. So I can write CH3, CH initially it was, but by attack of this hydrogen it becomes CH2. After that it is CH2 and this CH2 is attacked by BH. So that I'm going to write B and H with B, I'm going to write it like this. And on the left hand side of B, you can see that we have CH2 and then again CH2 and then again CH3. First mole we used here, the second mole here, and I told you we are going to use 3 moles of this. Now the third mole come into play, CH3, CH double bond CH2. Now what you need to do, again break this bond. Again you are going to break this bond. This will have positive charge and this will have negative charge. So this positive, according to anti-Markovnikov, will go to that carbon along double bond which has lesser number of hydrogen. And this negative charge will go to that carbon which has greater number of hydrogen. Very simple it is. Okay. Okay. So what I'm going to do, I'm going to write this one first. So I can write CH3 and initially it is CH, but by attack of hydrogen, it becomes CH2. And after that, it is CH2. And this CH2 is attacked by boron. So I made a bond with boron. But boron makes 3 bonds, which has another bond on the right hand side. You can see is CH2, CH2, CH3. And on the left hand side, you can see it is making a bond like CH2, CH2, CH3. Or we can directly write CH3, CH2, CH2 whole thrice 3 times boron. Can I write this? Tell me please. After this, you are going to do react this with H2O and H2O2. 3 moles of H2O2 in the presence of base. And this boron will be eliminated and OH will be added. So it becomes 3 moles of CH3, CH2, CH2, and then there will be OH. So this is the whole scenario of this. And this B will give you as a byproduct boric acid. Boric acid. If you are going to open it and then write it, you can also write H3BO3. Okay. And you will get propane one out. Propane. Everyone done with this? Are you done with this?
Yes.
Okay. So this is your preparation from hydroboration oxidation. Now after this, we have this reaction that we are going to do. Already we did in the chemical reaction of aldehyde and ketones and carboxylic acid. So from carbonyl compounds, So we are going to take aldehyde and ketone first. And you know that when you are going to reduce aldehyde, you will get 1 degree alcohol. And when you are going to reduce ketone, what degree of alcohol you will get? Tell me. If you are going to reduce ketone, what degree of alcohol you will get? Umam, do you remember? Basically, ketone is a bridging functional group, comes between two alkyl groups. So basically, it will give secondary. It is understood now. Understood. Very simple it is. Now see, this is your aldehyde. When you are going to reduce it with palladium, you are going to reduce it. That means addition of hydrogen will be taking place in the catalyst palladium. So how it will reduce? Very simple. The bond will be broken between oxygen and carbon. This carbonyl group, one of the bond will be broken. Hydrogen will be added there. Hydrogen will be added here. So what you will get? RCH2OH, alcohol. That means aldehyde reduced into 1 degree primary alcohol. Can I write primary alcohol? Very simple. Now, if you are going to use this, there is a ketone. This is your ketone. And if you are going to use this reducing agent, NaBH4. So this is also, you can see this is your hydrogen added here, hydrogen added here. And you will be getting RCOH, CHR, secondary alcohol. Secondary alcohol. In the same way, if you are going to oxidize this secondary alcohol, you will get ketone. And if you are going to oxidize with the mild oxidizing agent, this primary alcohol, you will get aldehyde. And again, if you are going to use that mild oxidizing agent, then you will get carboxylic acid. And if you are going to use a very strong oxidizing agent on primary alcohol, you will get directly carboxylic acid. Is that clear?
Yes.
This NaBH4, sodium boron hydride, is very important. It can reduce only aldehyde and ketone. It cannot reduce carboxylic acid, cannot reduce ester. So examiner is very clever. They are going to ask you question like this. Let's say this is the scenario, and they can give you a question like this. So first, and they will give you NaBH4. Now this is a reducing agent, but it has a power to reduce aldehyde and ketones. This is your ester. So ester cannot be reduced. So it will be as it is. It will be as it is. So only this ketone is present there. So this will be reduced. Hydrogen here, hydrogen. So you can see OH will be there, and the rest part will be as it is. Are you getting my point?
Mhm.
Right. Let me know when you are done with this. You done with this? Mom, please do respond.
Yes, sir.
Okay. Now the next from carbonyl compound is by reduction of carboxylic acid and ester. By reduction of carboxylic acids, and esters. Very simple it is. See, in carboxylic acid, we are going to use a very strong oxidizing agent. Reducing agent like LiAlH4 followed by hydrolysis. LiAlH4 followed by hydrolysis. Then you will be getting directly RCH2OH. RCH2OH. Basically, the reaction is taking place like this. RC double bond O. OH is there. So by this process, there will be breaking of this bond, hydrogen added. This carbonyl group totally broke. So what we have RCH2OH. Directly we get it. Okay. So if someone is going to give you CH3, CH double bond, this, you don't need to think anything. So basically there is no hydrogen here. Only the reducing agent is enough. So what will happen? This whole scenario will be converted. At the place of oxygen, there will be two hydrogen adding. So CH3 double bond will be as it is, CH2OH. Okay, but we cannot use this regularly because lithium aluminum hydride is very expensive reagent. Expensive reagent. So its alternate is basically first carboxylic acid will be converted into ester with the help of alcohol in the presence of acid, and then that ester with the help of hydrogen in the presence of catalyst will be converted into alcohol. Please do write. Let me know when you're done with this. No. Alternate method is this with the help of alternative of this. I'm going to show you. We have carboxylic acid. When you are going to react this with R-OH in the presence of acid. So basically, this is an esterification reaction that you have studied in class 10th as well. So this becomes RC-O-R dash. Basically, this hydrogen and OH will be combined to form H2 and it will be out of the in the solution in the form of water. Now, after this, what you are going to do? Reacting hydrogen, basically reacting hydrogen in the presence of catalyst. So this will be converted into RCH2OH, and the alcohol that you used here will be out, R-OH. I'm going to show this reaction. You can see, yeah, this reaction. RC double bond O, OCH3 is there. So what will happen? This bond will be broken. Carbonyl hydrogen will be added here. Hydrogen will be added here, and this oxygen carbon bond will be broken. Hydrogen will be added here. Hydrogen. So from the left hand side you can see RCH2OH you are getting, and from the right hand side you can see if CH3 is there, since we have R dash here, I should write R dash OH is there. So the alcohol that you used for the formation of ester, that you will get as well. Okay, let me know when you are done with this. I'm going to give you a question on this. Tell me the name of A, IUPAC name. Austin, am I audible to you? You are not responding at all. Okay, so see what will happen. There will be formation of an ester CH3, CH2, C double O, and this R is CH3. After this, you will get the alcohol that you have given here, CH3OH, and this will be converted into alcohol, that means CH3, CH2, CH2OH. That means propanol you will get and methanol that you used in the first step. Very simple it is. Please do write it and then let me know. The last preparation of alcohol we are going to do is from Grignard reagent, and it is a very important preparation. Grignard reagent. Now, when you are going to say Grignard reagent on aldehyde and ketones, let's say a carbonyl compound is there. That means either it can be aldehyde, or if it is R here and R here, it will be ketone. And if it is one of the R is replaced by hydrogen, so it will be aldehyde. Okay. So I'm going to take it like this, general. So whenever, let's say RMGBR, this is your Grignard. This is what Grignard or RMGBR removing. For generalization, I'm going to write X, RMGX. This is your Grignard reagent. This reaction, similar reaction, we have already studied. How you can see there will be negative charge, there will be positive charge. In aldehyde and ketones, we have studied, and there is negative charge, there is positive charge. Basically, this bond will be broken. Positive charge is here, so this is going to attack on this, and this bond will be broken, and this positive will be going to negative. So what we will have, this we will, and then you can see O negative, Mg positive, X, and followed by hydrolysis. Followed by hydrolysis. When you are going to do hydrolysis, you know that H plus OH minus is there. So negative will go to the positive and positive will go to the negative. So you will get this one. OH it becomes, and the byproduct you will get is MgOH. So this is how the reaction is going to take place in between Grignard reagent and aldehyde or ketone. Okay, this is the step how you are going to do it. So first write this mechanism, then we are going for the methanol and other aldehydes because it's a special, and ketone will be Grignard. Let me know when you are done with this. Are you done with this?
Yes.
system. So first I'm going to show you the reaction with methanol. And you are going to take uh, RMGX. So you know what will happen. Very simple. This will be, let me show you like this, HCHO like this. Or you can do this as well, not a problem. You know that this will be going like this, O negative, this is positive, this is negative, this is positive. So this will be attacking here and this will be going here. So can I write this HCH as CH2? CH2, O negative, Mg plus X. And you can see with C, R is going. So I'm going to write R here. RCH2, O negative Mg plus X. And after this, if I'm going to do the hydrolysis, H2O, you know that we will have H plus and OH minus. H plus will be going here and OH minus with this. So you will be getting RCH2OH with a byproduct MgOHX. This will be constant in every reaction for this type. And you can see you are getting primary alcohol. Have you got the mechanism? Yes or no? Second time I am explaining. Yes or no? Okay. So this is the product that you will get when you are going to react this methanol with Grignard reagent. R can be anything. Methyl, ethyl, propyl, butyl, whatever you want to take. Okay. Now, if I'm gonna give you ethanol, can you tell me the product? What degree of alcohol you will get? Tell me. Do it in two steps and let me know. If you got the concept, you can do this easily. Are you done with this? Mom, you need to follow the mechanism and you can get the answer. This will be going like this. So there is negative, there is positive. R is carbon, non-metal. So negative, metal is electropositive, positive. This will be going like this, and Mg will be attacking on this. So you will get CH3. CH is there, right? CH is there, and this R will be attacking, and then O negative MgX, Mg plus X. H2O has two parts, H plus and OH minus. This positive will be going to the oxygen O negative. So what you will get? CH3, CH, and down R I'm going to write on the right side, and this becomes OH. This becomes OH. That means secondary alcohol, and the rest part is the byproduct is constant. So what I want to tell you, very good, Ma. What I want to tell you is that except methanol, all aldehydes on treatment with on treatment with Grignard, Grignard, followed by hydrolysis, will give secondary alcohol. Will give secondary alcohol. And what about methanol? Methanol, methanol will give primary alcohol. Methanol will give primary alcohol. So very simple it is. Methanol on reacting or treatment with Grignard in the presence of followed by hydrolysis will give primary alcohol. But all other aldehyde, whether it is ethanol, propanol, any aldehyde, that will give you secondary alcohol. And then come to the ketone and do it by yourself, followed by the same mechanism. You can take R dash here, R double dash here, to not to be confused. Do the same thing, you will get it. Please do it. Will you be able to do it? If you are not, then let me know. Very simple it is. This will be going like this. So negative, positive. This is negative. This is positive. So this will be attacking on this. So what you will get RC. R dash is here, and this R double dash is attacking. And O negative, Mg plus X. After this has two part H plus and OH minus. You know that after this, H plus will be going to the negative. So what you will get R, C, R dash, R double dash. That means surrounded by 3 carbon, 3 degree carbon it is. So it is tertiary alcohol. It is tertiary alcohol. And the byproduct is your constant magnesium to magnesium OH will go and it will be like this. So all ketones, or you can say ketones, if treated with Grignard reagent followed by hydrolysis, followed by hydrolysis, will give tertiary alcohol. Tertiary. So this should be in your mind. They will tell you, when they will ask you if a carbonyl compound is going to be treated with Grignard reagent followed by hydrolysis. So which type of tertiary is formed? So what is that carbonyl? That is your ketone. Or if ketone is treated with this, what type of degree is formed? So that is your tertiary. Very simple it is. Let me know when you are done with this. You done with this? Mom,
Yes, sir.
no. Austin, no. Methods of preparation of phenol. We are going for phenol. So the first method comes from haloarenes. Very easy this. From haloarenes. To see how we are going to prepare, first we need to take haloarenes. That is your benzene directly connected with halogen. Let's say it is chlorobenzene. So first what I'm going to do, I'm going to react this with NaOH in the presence of the temperature should be very high, 623 Kelvin and 380. As you know that this haloarene uh, is not going to occur for the nucleophilic substitution reaction for haloarene is not possible at room temperature because it lost its at aromaticity, and also there is double bond character as well as phenyl cation. That's why we have to take a very strict or extreme condition, like the temperature should be very high, pressure should be very high. So this chlorine is replaced by this, and it forms phenoxide ion like this. And after this, you are going to treat this with H plus. So this Na plus will be replaced by H, and it becomes what? OH, phenol. This is what your phenol. So you are going to treat this with HCl, you can say. So it will be converted into phenol. So this is the first preparation for phenol. And this is very easy. Let me know when you are done with from halogens. Then we are going to do this. Let me know when you are done with this. Are you done with this?
Yes, sir.
Very good. The next is basically from benzene sulfonic acid. So basically, first we need to prepare sulfonic acid, benzene sulfonic acid. So we are going to treat this benzene with oleum. Oleum is H2S2O7, H2S2O7 in the presence of water. So this will be directly converted into benzene sulfonic acid. Very simple. After this, what you need to do is very simple. First, you are going to react this with NaOH. So again, this phenoxide ion will form, and followed by this H plus HCl. That Na plus will be converted directly into OH, phenol. So I think it's very easy. When we are going to talk about from diazonium salt, this reaction we already studied half of the reaction in haloarenes. We are going to take aniline, benzenamine. Aniline is a common name now treated as IUPAC, and react this with nitrous acid, NaNO2, in the presence of HCl. In the presence of HCl, this is nitrous acid. So we will get diazonium salt, and it has a name. You can see this will be converted into N2 plus Cl minus. and this has a name, benzene diazonium chloride. Benzene diazonium chloride. And after this, you are going to do the hydrolysis with warm water. Warm water. This N2 plus Cl minus will be replaced by OH with the evolution of N2 gas. With the evolution of N2 and HCl as well. Water has two parts, OH minus, H plus. So H plus will go with Cl minus, N2 will be in the gaseous form, and then H or Cl combined to form HCl. Let me know when you are done with this.
Done.
Okay. The last preparation of phenol that is left is your from cumene. From cumene. So from cumene, so first I'm going to write the structure of cumene. This is your benzene, which is connected with isopropyl. So this is your cumene. First, you are going to react this with oxygen, oxidize this. So this oxygen will be going in this between carbon and oxygen and form peroxide like this, COOH. This is your peroxide, and this has a name, cumene hydroperoxide. Cumene hydroperoxide. After this, you are going to react this with hydrolysis. You are going to do in the presence of water. So you know what will happen. This whole quantity will be eliminated. So what it is? It is basically CS3. CS3 single bond O. Carbon makes four total bonds, so double bond. That means propanol you will get propanol. And this OH will be directly connected to this carbon, so you will get phenol. This is your phenol. Please do that. And let me know when you are done. Are you done with this?
Done.
Very good. Please do this. Both of you done with this? Mom,
1 minute. You are done.
okay, so this is catalytic hydration. So OH minus Markovnikov, it will go here, and H plus that will go here. So it will be CH3, CH, OH, and then CH3. After this, NaBH4 can reduce aldehyde or ketone only. So this is your ester, it cannot be reduced. Only ketone will be reduced. This will be reduced. Hydrogen, hydrogen. So cyclohexane it becomes, and this is OH. And the rest part will be as it is. C double bond O, OCH. This is NHBH4 and only aldehyde. Aldehyde it can reduce. So the rest part will be as it is. You can see, and this CHO will be converted into CH2. Is that all of it correct, or is there any mistake?